Well, good morning, everybody. Here's our plan for the forecast video today. We're going to walk through this May and what's got our pattern stuck so hard into giving us so much severe weather, which again, this morning we're watching a large complex of storms coming through this section of Texas. I then want to walk through some of the recent stats on precipitation. I'm going to then give you any sort of an update I might have on sort of a pattern shift and what it would take to overcome some of these larger forces that have driven the pattern we've had in May. We're then going to stretch this out a bit farther and look at all of the long-range models once again, look at an analog year and why I still have a lot of kind of thoughts about 2020 as a stronger analog. We're going to finish up with a hurricane forecast and a 3-model outlook at the global update. So the animation we've been watching kind of shows us what happened last night. In fact, I want to pause it just as last night as the sun set. Large storm system that was exiting. This is the one that produced multiple rounds of extremely heavy rain and severe weather through a large section of the country over the weekend, including the one that delayed the Indy 500. This is the low that did that. But I want you to take note of all the wildfire smoke that still sits down here in parts of the Gulf of Mexico. That's going to be critical to understanding where I think this pattern is going to go. In the overnight hours, we watched storms that followed a boundary right in through here just as the sun set, producing locally heavy rain, some very large hail. And then this morning, a storm complex is just feeding into that already moistened air. And this morning, this is what this large storm complex looks like. This is severe storm warned for hail and straight line wind damage. Maybe it's easier to see it here on radar. This is what it looked like just as I was recording and as I play this for you. Notice the little boundaries on which these storms formed yesterday. We've had an abundance of those helping to initiate huge storms with all of the local moisture that's been supplied here to these. And this morning, this has turned into a little mini bow echo as you watch the very end of this animation. So individual storm cells yesterday on the Red River overnight, and then right there, that bow echo coming through, delivering a lot of damaging wind just to the north and east of Dallas. It's been an extremely busy last, month, but just to take you back to the 23rd showing you storm reports, we had 515 on the 23rd. Going over to the 24th, we're going to add another 265, including 19 tornado reports. We then get into the 25th. This would be where we add another 454 reports, including some extremely large hail on the 25th. The 26th, this is our new busiest day of the year at 1,231 reports of severe weather. Just to understand something here, the busiest day in terms of storm reports that the Storm Prediction Center has ever received was on April 4th, 2011, I believe it was. April 4th, 2011, they had, let's go look at it real quick. I think I can put that in the top here. Okay, 2011, 04. Yes, that's the busiest day at 1,476 reports of severe storm damage. Now let me take you back to to the 26th, just looking at over 1,200 reports of severe wind damage. That was the 26th, and we can also look at the 27th, and early this morning we're getting these storm reports right down here. Now, when you think about it all, this is what the 2024 preliminary storm reports look like. I've showed you this before, but I want to show you that the lion's share of these reports have come in the month of May. That's May only, and this is the entire year. So it just shows us how active this 1 month has been. Another thing to have a look at here, I'm going to show you some stats. If you're curious where we sit on the daily count compared to the annual trend of tornado reports, we're well above the historical average. Hail is above the historical average. Wind reports also very high compared to the historical averages. We can see this compared to previous years. This is our wind count compared to averages. Hail reports here, again, above average. And take a look at the tornado reports. Top 3 in terms of the last 15 years when we look at those years in comparison. And then if you want to do this a bit more statistically, this is the inflation-adjusted annual tornado trend. So this is where we have gone through and removed overcount or removed duplicate counts, which still sit in the database. And if you look at the distribution, we're near the very top of it. I don't think I'm surprising anybody with this, but it's absolutely exhausting to try to keep up with just how much severe weather has been across the country so far this year. In addition to that, each one of these storms has delivered a lot of rainfall. And this is just through the last 7 days looking at total accumulated rain. And I've got more respect for this map that I make right now because I live right here. And the rains we had on the weekend, Friday primarily, and then again on Sunday. That's it. That's my little spot right there. And there are fields flooded out all around me. So to think about that color, which is right in through here, and then compare it to what's come through parts of Missouri, southern Illinois, Kentucky, Tennessee, down into Arkansas, Texas, Oklahoma. And then, of course, what we saw last week with the incredibly heavy rains that rolled through this part of the western Corn Belt, getting into the upper Midwest, I can now just appreciate how bad the flooding has been. It's also important to note how far we can see, how far to the east we've had this dry line feature right in through there, which just cannot be ignored in this pattern. From here, I want to show you the last 14 days of percent of normal precipitation. And again, it's just to identify that what we've been talking about, some of these areas getting hit so much with heavy rainfall. There are significant portions of the western plains down here into western Texas, this stripe through Mississippi, Alabama, Georgia, into South Carolina, southern Florida, and parts of New England that have been drier than average despite how active this pattern has been. And when you look back over the last 30 days, the top thing I want to be thinking about is how is the dryness in Mexico influencing these areas? We have to talk about that because I think it's to be a critical piece to understanding where this pattern is going to go. But to finish up this kind of discussion, I'm going to give you a few more points of reference. This is our month-to-date precipitation ranks. And you start to see a lot of single digits in this, from the Red River Valley of the north to the Red River Valley of the south. Parts of Iowa, a lot of single digits across Iowa, just showing you repeated storms that have gone through this area. And what's really changed a lot in this month of May has been this region here from the Mid-South, especially Tennessee and Kentucky. And just remember, back in April, we were talking about drought in parts of Virginia and in North Carolina. The Gulf Coast has been wet, but those drier areas have me concerned. And what are we seeing when we see this part of Florida dry? Mexico extending this dryness into these areas. This tells us where the high pressure lingers to our south. And what we need to understand is where that's possibly going to go. Because while we have made a massive recovery in soil moisture, this is down to 100 centimeters or 40 inches across these areas. So hydrologically, we've broken long-standing drought in areas. This cannot be ignored. These drier areas have to be continued to be monitored as they are source regions for the flow later on this year that I think are going to be, again, just important to watch evolve. So that's your latest soil moisture map. This is where we currently have rivers in action, minor, moderate, or major flood stage. And if we look at our U.S. drought monitor, we are now down to about 12% of the land area in the lower 48 in D1 to D4 drought. And again, I'll have to stress these areas and why I think they're going to be critical to watch over the coming weeks and months. If we look at cumulative downward solar flux, I just want to point out that so much of the Canadian prairie has been under cloud cover. We've seen a lot of these storm systems that have come through curl up and sit and spin over Manitoba and Ontario, north of the Great Lakes into Quebec. And this has really robbed the area from a lot of sunshine. And that's going to be critical given that the moisture's been recovering in this area. But it's not been just a quick jump on the season because of the lack of good sunshine for a while. Meanwhile, also parts of Texas have been missing out on quite a bit of the sunshine too. All right, here's where we get into this pattern discussion. And if you want to know if there's a failure mode in what I'm about to share with you, it's going to come from this. Now, I want you to keep your eye on that because water's been getting cooler in this area. We continue to watch our La Nina develop. This region, which had been cool, is beginning to fill in warm. The main development region for hurricanes continues to be record warm. But I want to keep an eye on this because despite everything going on in the tropics, in the Atlantic, this area of very warm ocean temperatures has driven the pattern that we've been seeing up to this point. We've talked about it for weeks now. So if there's going to be a failure mode in this upcoming forecast, because you're going to see models attempt to drop a trough right into this. That's a trough of cold air. Where does the cold... This is what's so important about this. Why? Let's just do this. Why has there been so much warm water here? Well, the skies cleared out early. The sun beat down in this area. We had a lot of cloud cover here. We had very rough seas. We also had stronger flow coming through this area. But this was missed. So the sun beat down in this area. It got hotter and hotter. And the warmer it gets, you get this positive feedback cycle, which produces higher pressure. That's what has to be overcome. That's what's been driving this pattern. And the patterns look like this. So there is the fast flow coming around the trough here. There's been another trough north of Hawaii, but there's been ridges, one there and one there that's been so supportive of the pattern driving the flow into the western United States. Now, what's been missing? The missing thing is here. There's not been a big, strong Bermuda high that even migrated in some years over to parts of the southeast to make this even worse. That Bermuda high is not in place. It's lower pressure. There's higher pressure here. There's been higher pressure there. And had this been a year where there had not been the pattern being driven by the big warm blob of water north of Hawaii, I would have been extremely concerned about these two ridges vacating the Atlantic Ocean. Now, we need to care about them now and start to watch what they're going to do going forward. But the Pacific high has been what's been most dominant in this pattern. And we want to know if anything about this particular pattern is going to change. Because what it has done is it's also allowed, starting way back in March, for a lot of heat and dryness to build in the Bay of Campeche into Mexico, into central Mexico. And that dryness has at times moved here and it's moved there. This is a map of the month of May looking at relative humidity anomalies, the blues being where it's been wetter than average in the lower atmosphere. I'm talking about moisture, and the warmer colors representing where it's been drier. We've got some places here that are almost 30% in terms of humidity drier than average, and that is substantial. This is what's informing my longer-term forecast as we go forward. So going forward, here's what I want to know. We know that about, 3 weeks ago, I was thinking that by the time we got to this point in May, actually 5 days before now, this pattern would have broken. And we tossed that forecast out the window once we saw the failure mode come into place. So do we have another failure mode? Artificial intelligence says active through the 30th, 31st, 1st. We've still got the same old thing. See the trough tossing momentum into the West United States. It's diving in through here. There will be multiple systems that continue to cross the country. This is what I want to know. This is the 3rd of June, getting to the 4th and 5th. Now, what is happening in the models is you see where the ridge is going in, the higher heights? These have been living there, driving these troughs across the country. And the models around June 4th, 5th are trying to drop a trough in here and extend this one out through the Canadian prairie. Now watch this, because the moment they do, what fills the gap in between is a ridge. So here you go. This is the 5th, 6th, 7th, and 8th. And this is new. These troughs have been living here. That's flattened this flow out, producing multiple systems across the country. We've had ridging in this place, and the models are yet again saying, oh, no, drop a trough in that area. And we have to just ask, is that possible given this? Now, why I brought this up a minute, why is this heat so important? What is a trough? A trough is an area in the atmosphere of lower heights. Okay, hit thickness. The atmosphere is compressed because it's cold. We've had warmth underneath this for so long. We're suggesting a trough gets dropped into that area. I think that this, again, is going to struggle to do that. We have to just wait and see. But I will say this. It's not just here in the artificial intelligence forecast. Let me go to the European ensemble. I'm going to have to go back to the 0Z run to show it to you because the 6Z run only goes out 144 hours. There's that same time frame, the 7th and 8th. Looks almost identical to the AIFS system. What about the GFS ensemble? Very similar as well. So despite the fact that I have 3 models attempting to drop a trough right where there's a bunch of warm water, this is that's the failure mode with this. But if this does occur, this whole pattern is going to slow down, it's going to amplify, and there's going to be a lot of heat that builds into this area. And that's what we have to be talking about. Could that be the beginnings of our summer pattern? All right, let's get into it and discuss it. Here's our all hazards weather map this morning as I was recording. Severe thunderstorm watches throughout this area, severe thunderstorm warnings as we saw the bow echo going through. Heat to the south, and then we have a frost advisory up here in the parts of Minnesota. Next, I want to show you the flow today. This ridge is going to toss a little short that's going to come out into Texas. Watch the storms explode on that. This trough continues to move in, giving us storms here. And there's going to be on the back side of this low, which is interesting, some convection rolling right in through this area. And that's why today's convective outlook shows 1, 2, 3 different areas of storms. If we then get into day 2, we're going to watch a skinny area right here in the western and northern plains give us the risk of the strong to severe storms. And day 3, which will be the 30th, this is again going to go down to the southern plains. From there, let's go have a look at some of the new maps I'm producing. I'm pretty excited about this. Every bit of time that it rained this weekend, if I had some time, I worked on these new maps, and I expect to release all of them to you very soon. They're going to be mobile friendly. They're going to have multiple regions. We're going to generate about 30,000 maps a day on this new technique I've discovered. Pretty excited about it. Okay, this is the high-res NAM simulating radar reflectivity. There's this morning's storms. We've talked about these. Now, as we go forward into this afternoon, watch the storms erupt right in through here, the scattered storms on the backside of this low here, and then watch the storms come into parts of the Pacific Northwest. By the way, what'll be fun is you'll be able to get all of this regional now. So if we just say, show me those storms in the south central U.S., here they go. Higher resolution images, easier to load on mobile devices. I'm pretty excited about this, something I've wanted to make for you all in a while. But this is how these storms continue to play through the day today, getting into Wednesday morning. Now let's go back to that larger view and just see how things shake out. This is now Wednesday morning, Wednesday midday. You can see the time ticking away right here. And as we get into Wednesday evening, it's going to be right in through this quarter that the biggest storms are going to sit while we watch storms exit through parts of Pennsylvania, Virginia, West Virginia tomorrow. Playing this out through the end of this run, we're going to watch the storms move into the western Corn Belt by the time we get into Thursday. From here, quick 5-model rundown. This is the artificial intelligence forecast for the next 7 days. Take note of this. This is what the forecast is from the national blend of models. Again, this will be one of my maps that gets updated very soon. Extremely wet from Texas through the plains. Drier in the mid-Atlantic. Once we get here, this is the WPC forecast for the next 7 days. Extremely wet into this area. This is the European model showing the same thing. And then as you see here, here's the GFS. If we look at the probability of getting at least an inch of rain, it is highest into this corridor. I know we got a new model run in, so when I click on this, it'll go to that new model run. But let's go back and show you the old one. 7 days out. This is the chance at 7 days out on getting 2 inches. And if we stretch this out over 10 days, this is the probability of getting 2 inches of rain in the next 10 days. Let's take that back down to 1 inch so we can kind of get an idea here. Most of the next 10 days, so through the 5th and 6th, until the trough attempts to land on top of that warm water in the North Pacific, we stay quite active. So to show you that quickly, let's compare models, the GFS on the left, European on the right. I'm picking this up this evening where we're going to be watching these storms through this corridor, storms on the back side of the low here, and then some entering the northwest. There they are. As we play through Wednesday, again, Wednesday's risk is going to be into this area, into the overnight hours, and also down here in the southern plains, while some storms, try to exit here in the east. Going into Thursday, we're going to watch that frontal boundary to slide its way farther to the western Corn Belt, stretching down to the Red River Valley of the south, around high pressure sitting here. And as we get towards Saturday and Sunday, what keeps this region driest the longest is going to be the high pressure sitting over the top, producing stormy conditions just on its western periphery. Now this is the first. Getting to the second and third, we continue to see wetter weather in through this area. Remember, this pattern doesn't change until the 5th and 6th, so let's get out there. There's the 4th and the 5th and the 6th. Now what's going on that's different is there's no longer a deep trough of low pressure coming in this area. And if that's truly the case, and high pressure begins to build into this region, it's going to change this entire pattern in a big way as we go forward. So we have questions as to whether or not that's possible. But the longer range models are suggesting it. Just take a look at the flow pattern through the 8th, 9th, and 10th. Ridging settling in here, troughs of low pressure staying farther into the Gulf of Alaska and out into the open Pacific, and flow coming in out of the northwest here. Now, early June northwest flow does not produce storms in this area. If it was July or August or even September, we'd be talking about this being a stormy corridor, but not right now. So what that all does is that ends up giving us a week 2 time period that shows up drier, June 4th through the 10th in this area. And we're wetter into the northeast. Why? Because the flow comes in and makes the turn. Remember earlier I said watch this area down along the Gulf Coast? I do not like the ensemble model forecast for the Gulf Coast. These models tend to not be able to pick up on the summer convection that happens along the Gulf Coast. Stick to the CPC here. So that's your week 2. Before we stretch this out any farther, let's talk temperatures. Frost risk over the next 7 days. We talked about where this cold air is, but we have some cool air coming into the northwest as well. Here's Tuesday's lows. We already saw these this morning. But getting into Wednesday and Thursday, quite a bit of colder air around the Great Lakes and also here in the Northwest. From Thursday into Friday morning lows, Saturday morning lows, getting into Sunday and Monday. A lot of warm air coming in as we get out to there to June 3rd. Take a look at the high temperatures today on Tuesday, Wednesday, Thursday. Watch the heat come right back into this part of Texas by Friday into Saturday. Watch, here it comes in. There we go into Sunday and Monday. And this is where we start to see the pattern wanting to do something a bit more like this once we get past the 3rd. So as we stretch it out, this is the next 7 days total accumulated GDDs according to the National Digital Forecast Database. Go ahead and pause it here if you want to take a closer look at what we're expecting. This is what I've got in terms of the GFS forecast for day 5 through 10, and this is day 10 through 15. And this is what we have to watch. Can the pattern really do something like this in terms of its flow? This would be a substantial return of heat into the west, which is going to be critical to the longer range forecast. It's not just there in the GFS, it is also in the European. That's day 5 through 10, and here's day 10 through 15. This is a massive flip in the pattern if it does occur. The failure mode is getting a trough to live there. If that does not happen by the 5th, 6th, and 7th, this is all gone. Everything I just showed you is not right. But if it does occur, this starts to get us into the major concern I have for the longer range. So let's have a discussion about that. This is what the newest update from the CPC is for June 8th through the 21st. And now we start to see them showing the heat coming into this area as well, which suggests the pattern doing something a bit like this. We're wetter into this corridor. Why? Because that'll be the base of the trough, right into there where we have our best rising motion. Will likely be drier into this corridor if this is the case. Is there any support in the longer range European? Watch the heat build once we get past the 5th, 6th, and 7th. We got out here, and we just continue to see the models through the end of June, all the way through. This is the 4th of July, trying to build in a lot of heat into this area. On the precipitation side of it, let's just look at the 1 month ending on the 4th of July. Underneath that ridge, it's expected to go drier. Now, here's the question we have. Is this ridge large, or does it mainly live in the southwest? Because if it lives in the southwest, what we end up getting once we get toward the end of June is storms cascading over the top of this that no model will be able to predict. And that is the scenario that I think we're going to have to be watching. That's a killer for the southwest monsoon. But it would be something that would drive storms in already saturated ground right over the top of this area once we get into late June and early July. Is there any support from that from other features like the MJO? Well, if the MJO does sweep through phase 4 and 5, a lot of June could end up with flow that does have troughs here and ridging in the middle part of the country in a trough east. So there is some support for the possibility of this happening if the MJO can outdo the warm blob that's in this area. That's phase 5 into phase 6. Again, see that? This is what we're questioning today. But as if that flow comes over the top, that will bring a lot of heat into this area, and we will get into a pattern for ridge riding storms soon. But again, I'm just questioning this. Can we outdo that? All right, what else has changed since this has occurred? Well, remember, cooler water continues to live here. La Nina builds. This cooler water is gone. The Atlantic has been quite warm. And as I think that through, I just want to give you a quick review here of the long-range models. They're going to update in about, 6-7 days. This is the new CPC, June through August forecast. Not new, sorry. It was released on the 16th of May. This was the ECMWF forecast released back at the beginning of May for June, July, and August. This is the NMME forecast, June, July. August. And pause the video and look at these maps so you can have a closer look. This is the IRI forecast. We've reviewed these. I just wanted to show you them again. What I'm getting hung up on is how much 2024 continues to remind me in the future of what 2020 did. Like the newest forecast from NOAA on the hurricane season, they've gone with an 85% chance of being above normal. Now, this was released last week, so sorry I didn't produce a video after it was released, so this is my first chance to talk about it. This mimics nearly every long-range forecast we've got on hurricanes. And just so you know, this is the most aggressive NOAA has been in May at forecasting the activity for a hurricane season. Why I'm thinking so much about this is because by the end of June in 2020, even though May 2020 looked nothing like this May, this warm water built into this area. while weak La Nina conditions formed. This water stayed cool. The Atlantic stayed warm. And even though we had some cooler water moving into this area, there's a lot about this that looks just like this year. Now, this is the way that the end of June, 1 month from now, could be. And my concern is what happened in 2020 was the heat built into this part of the Southwest, the dryness built into this part of the Southwest. We had time periods of heat and some flash drought that rolled through this part of the country, but it was always followed by huge rounds of storms, including a derecho that hit Iowa in August 10th of 2020. Now, I'm not, again, saying that that's going to happen, but there's just a lot of similarities about 2020 I can't ignore. You say, what's your confidence, Eric? I'm just going to spell it out for you. Low. I don't know this perfect. I'm just saying I got to think it through. So that's my newest conclusions about the longer range. Let's get into international weather. 3 maps. This is the 10-day outlook from the European just released this morning. Take note of the drier forecast in southern Brazil. That's the first time we've seen a drier forecast there in months. Take a look at how wet it's going to be across parts of Australia. Southeast Asia wet. And the big question is this area. Because the ECMWF operational is the only one showing wet in through here. The artificial intelligence is not as wet right there on that side of the Black Sea. But it is dry here, suggesting there's more to this pattern shift that's possible, given that we're breaking it down in other parts of the world. Same thing for parts of Australia. And finally, this is the GFS. Now, a little different projection. This will all be fixed when my new maps come out. But we are drier here in the GFS. So the new European 10 days got me a bit confused because it doesn't quite align with other forecast models. But we'll leave you at that, and I'll look forward to talking again tomorrow morning. Thanks.